Hello, everyone. Thank you for joining us for another live webinar session hosted by EE Tech and All About Circuits. My name is Dale Wilson. I'm the Director of Engineering and Content for EE Tech and All About Circuits, and I'll be your moderator today. Today's session is brought to you by Omron and is titled AC and DC High Power Relay Solutions for the Energy Market. Let me tell you about our presenters. Kyle Alberti attended Northern Illinois University, where he obtained a Bachelor of Science degree in Mechanical Engineering. He also holds a Bachelor of Arts from Carthage College. Kyle is currently a business development manager for Omron, serving as the America's technical contact for Omron's relay, sensor, and component products in energy applications. Zach Hendricks also attended Northern Illinois University and obtained a Bachelor of Science degree in Mechanical Engineering with an emphasis in sustainable energy. He is currently the relay product manager for Omron, serving as the America's technical contact for Omron's relay products. He has expertise with relay applications within the automated testing equipment, factory automation, and smart home building industries. Following the presentation, we'll have a live Q&A session with Kyle and Zach. You can submit your questions at any time during the webinar using the Q&A section on the right-hand side of your screen. I would also like to mention there will be several poll questions during this presentation. Make sure to watch out for them and answer them for Omron to understand more about your consumer needs. We will also provide our attendees a downloadable copy of the presentation and some data sheets near the end of today's session. These will be available in the Handouts tab. Thank you so much for joining us, and with that, I'll hand it off to Kyle and Zach for today's presentation.
Great, thank you so much for the introduction, Dale. And as mentioned, I'll be discussing today Omron's AC and DC high power relays for the energy market. Before jumping in here, I would like to bring up our first poll question to understand what brings you to today's webinar. Great, thank you. So some background on Omron. Omron is a leading global technology innovator and is comprised of four main businesses: social systems, solutions, and services, offering social infrastructure systems for a safer and more comfortable society; healthcare, providing comprehensive lineup of healthcare products for home and hospital use; industrial automation, offering innovating global manufacturing through factory automation; and device and module solutions business, or DMS, which is the business unit that Zach and I belong to. Omron DMS provides the market with sophisticated components that create a seamless relationship with people and machines. So going into a little bit more about Omron DMS, we provide many solutions such as sensors and sensor modules, including MEMS sensors, photomicro sensors, time of flight sensors, and more. We offer a wide range of connector solutions, including FPC, FFC, DIN, board-to-board, and flat cable. We offer switches such as general purpose, tactile, sealed subminiature, and trigger switches. And finally, a wide range of relay solutions from MOSFETs to automotive, solid state, signal, latching, and high power relays, which will be the focus of my webinar today. Omron has selected four key domains to target social issues to achieve a carbon neutral society and realize a digitalized society by utilizing Omron's expertise and core competencies. These domains include devices for DC drive and devices for DC infrastructure to help achieve that carbon neutrality, and high frequency and remote VR devices to realize a digitalized society. I work within the team for DC infrastructure with a heavy focus on applications such as PV inverters, battery energy storage systems, EV chargers, and other energy infrastructure applications. So as part of our selection for solving social issues within the energy infrastructure, Omron has made the commitment to create key components and devices by leveraging our technology and our core competencies to help achieve a carbon neutral society. Our focus is to reduce carbon emissions in the energy sector and to expand our solutions within energy power generation, energy storage, and energy management. We will aim to realize a carbon neutrality by leveraging our devices for safe shutdown, sensing, and low power consumption in order to support a more efficient and more reliable energy equipment and infrastructure. In focusing on a carbon neutral society, we've really identified many challenges within the industry, including minimizing installation and maintenance costs, improving reliability and safety, and maximizing power efficiency. To combat these challenges, Omron brings value toward high power relay solutions, moving away from those bulky and costly contactors to provide the market with high power PCB relay solutions with reliable and efficient fail-safe designs and low contact resistance features to greatly reduce heat generation and optimize heat dissipation in order to maximize that power efficiency. Now I'd like to introduce our high power AC relay lineup. So Omron is committed to investing in the expansion of our PCB relay product lineup with high power AC and DC relays for the growing energy market applications, including PV inverters, energy storage systems, and EV chargers. For the purposes of today's webinar, as we are discussing high power relays, I would first like to note that I'll be only looking at 30 amps or more for the AC side. Omron has many more product offerings at lower voltages and current levels, but for the focus of today, we're looking at 30 amps and above. So you can see here from the legend that we primarily have your typical 1-4A open and closed relays. In the dark blue here at the bottom, you can see we have two latching relay offerings. And at the beginning of July, we added our 4-pole relay with an auxiliary contact option. So looking a little bit more at each of these, I will start from the bottom left and move up to the top right in increasing power. So we really started building out this lineup with lower voltage, high current AC relays for residential type applications. And then we really expanded from there, gearing towards contactor replacing high power, high voltage and current relays up to the upper right side here of the chart. So on the lower end here, you can see these residential relays, the G7L PV and the G6QE rated from 250 to 280 volts AC and up to 36 amps. And then we expanded from there to support up to 800 volts AC, 40 amps with the G7EB series. You can see the G7EB series from 40 amps all the way up to 100 amps and 120 amps for the G7EB-E high capacity version. And coming soon, we'll even have available the G7EB E2 for an even higher capacity of up to 150 amps. So moving back over to the left here, we have our new 4-pole G9KC relay rated at 40 amps, 480 volts AC. And this also has an option for an auxiliary contact, making it either a 4A or a 4A1B form factor. Also coming soon for lower current and a smaller package type applications is our new G6QG rated at 480 volts AC, 55 amps, and that's targeting release later this year. On the bottom side in the darker blue, we have our latching relays, the G9TA 60 amp, 250 volts AC, and the high rated G9TB at 120 amps, 277 VAC. And then moving up to the top right here, we have our G9KA series for a much higher capacity power and switching. The standard G9KA rated at 260 amps carry, 200 amp break, and 800 volts AC. And the high capacity version is capable of 1000 volts AC at 300 amps carry and break. So I'd like to share a little bit more of some of the value of some of these AC high power relays by touching in more detail on some of the focus products I just mentioned in the previous slide. Starting with our G9KA series, we see we have both the standard and high capacity -E type here. This is the largest and most substantial AC PCB relay Omron offers. You can see that dimensionally they're very similar in size. To support the thermal performance of the high capacity version, we've done some modifications to add larger legs to allow for more heat to escape beneath the relay. And we've also expanded the terminal pads to increase the surface area for great heater dissipation. Looking and talking about the rated E-life, the main ratings we have here are the make, carry, and break ratings. For the high capacity version, you can see up to 300 amps for the carry and break, and slightly smaller power systems with the G9KA at 260 amps carry, 200 amps break. We also have ratings at a lower break capacity if you're looking for a higher number of operations and a relay that is capable of switching at different applications, but you're not expecting to break the full load and are looking for a long lifetime high capacity type relay. So the G9KA standard type also has, as you can see here, a DC rating at 60 volts DC, 200 amps. And we'll look at adding the DC ratings for the high capacity G9KAE in the near future. Coming down to the specs here, the major call out for both of these relays is going to be the very low contact resistance at 0.2 milliohms. And in the coming slides, I'll discuss more of the benefits of such a low contact resistance and what this really translates to in these high power type applications. These relays feature a 4 millimeter contact gap, making them viable for high power applications, a long mechanical lifetime up to 100,000 operations, and coil voltages are available in 12 and 24 volts. And then also to call out here, we have a lower coil holding voltage that can be dropped from 5 watts to just over 1 watt. So the main value proposition for the G9KA series is our low heat generation technology, which really allows designers to shift from contactors to PCB type solutions. Our technical advantages are very low and repeatable contact resistance in a compact PCB relay casing. Our value proposal is allowing designers to replace contactors and reduce heat sinks and any heat mitigating designs, allowing them to reduce production costs, lower the height and weight of their designs, and reduce component costs to ultimately allow for a more compact and cost-effective product design. So as I mentioned, one of the biggest features of these relays is the low contact resistance. And that is where a lot of our engineering resources have really been focused in the design of this product. We have been able to realize this low heat generation by utilizing a combination of proprietary technologies in the design of the relay. They feature a unique structure of double break and twin contacts to realize the low 0.2 milliohm spec. And what this ultimately means is there's more points of connection to maintain that high reliability and realize that low contact resistance over the life of the relay. We also utilize a contact material with high electrical conductivity to allow us to realize the very low contact resistance. These relays are designed with a plunger type structure to realize a high endurance with reduced power consumption. And the plunger structure helps to prevent any potential for contact welding, especially due to the high conductivity of the contact material, ensuring that the contacts don't stick and you can disconnect as and when expected. And then lastly, we have heat radiation terminal pads to release some of the heat that's generated. There is a lot of features here, that can help reduce the heat, so ensuring it's a really substantial alternative to the traditional contactor solutions. So to demonstrate the high thermal performance and reliability of the relay, we can see here on the left that there is a very minimal rise in contact resistance from the 0.1 to 0.2 milliohm over the life of the product, 30,000 operations at 300 amps carry at the holding voltage. And on the right side here, on the temperature rise test, you can see that this is really how what that low contact resistance translates to in terms of low heat generation. So you can see a comparison simulation from the conventional high power relay rated at 0.4 milliohms to Omron's G9KAE at 0.2 milliohms. And that small amount of difference, just 0.2 milliohms, really translates to a large gap here, 67.7 degree shift in the thermal output at 300 amps and 480 VAC. So it's a really great advantage in the G9KA series is that low contact resistance to help that heat mitigation. So before moving on, we just covered a lot in the G9KA. And so I'd like to ask another poll question to better understand the challenges of those members on the call today. So what are the design challenges you face with your current relay or contact solution? Great, thank you. So the next series I'd like to discuss is the G7EB, which is a lower power solution, slightly lower power for slightly lower power systems than that of the G9KA. The G7EB was really our first kind of step in towards the higher power sector, moving into industrial or commercial type energy applications. We currently have both the standard G7EB and the high capacity G7EB-E, and we are expanding this further with the coming soon release of the G7EB-E2 that I highlighted earlier. For the standard G7EB, we can switch up to 100 amps 480 VAC, or for higher voltage applications, we can have 40 amps 800 VAC make and break. And we can carry up to 120 amps with the -E high capacity version. And then with the coming soon release of the G7EB-E2, we'll be capable of up to 150 amps of rated carry current. Taking a look at the specs here, we have coil voltages available in 12 and 24 volts. And again, a holding voltage feature that can drop the coil consumption from 2.8 watts down to 575 milliwatts at that holding voltage. The series features a 5 milliohm contact resistance, a contact gap of 3.6 millimeters. So again, greater than that 3 millimeters, making it a great relay solution for energy applications. And then finally, a high mechanical life of up to 1 million operations. So we briefly talked about it for the G9KA, but on this slide, we're really highlighting the reduced holding voltage for the G7EB series. And for all these high power relays that I'm discussing, we'll see a holding voltage rating available. And this is to reduce the power consumption by these high power relays that have larger coils for that high power requirement. So this is a great benefit, not only to reduce power consumption, but also to ensure that the relay is performing to the specification and you don't have any additional degradation of any components due to high coil temperature outputs. So what you're doing here is you're building into your input circuit to provide the coil at 100 to 120% of the rated 12 or 24 volts. And then you're dropping that down after 0.1 to 0.3 seconds to 45 to 65% of that rating, allowing the large drop of power consumptions. In the case of G7EB, we can see a drop from 2.8 watts to 570 milliwatts. So a lot of power savings can be had by this feature of our high power relays. Up next is our G9KC multi-pole relay, and this is a very new MPI for us. This relay is rated at 40 amps 480 VAC. It has 4 poles and also comes with an auxiliary contact option. So this is a really new, exciting product series for us, aimed at multi-phase or 3-phase AC applications, and really, I guess, any 3-phase application in general. The poles are mechanically interlocked to ensure switching at the same time, and the auxiliary contact option is available for contact weld detection. So it is using a very low signal path to this auxiliary contact to assure that the state of the relay is properly represented, and there is no contact welding or sticking, and it has, properly switched as intended. As with our other relays, the G9KC has a low contact resistance of 6 milliohm max and a large contact gap, making it suitable for applications like EV charging. And then also to note, we comply with high amperage short circuit testing, and we have a holding voltage feature for this relay as well, dropping it down from 2.8 watts to 575 milliwatts. So the last 2 products that I'll be discussing on our AC side is our latching relays. If you're not familiar with these, latching relays allow you to pulse the coil for the contacts to latch in place, either magnetically or mechanically, for a continuous operation of that relay without draining power at the coil. To unlatch the contact of the output, you again pulse the coil and you're back to the open state. So for looking here at the G9TA, where you have a 60 amp 250 VAC rating, it has a low contact resistance of under 2 milliohms and is offered in a 12 volt coil voltage. And a big point I'd like to highlight here is that it's offered in both a single and double coil. So what that is really, so a single coil uses just one coil to change the state of the relay. When a pulse of the current is applied, the coil moves in the coil moves the contacts to closed position to change that state. If you reverse the polarity of the pulse, you can return it to the open state. Now, a double coil has two coils spun in reverse polarity. So one coil is used as a set or close, and the other coil, is used to reset or open the relay. And I'd like to point out, you can see here from the G9TA, it's also offered in 3 termination types. We have welding terminals, M5 securing screws, and PCB mountable. Okay, the next is our G9TB higher rated latching relay at 120 amps, 277 VAC. It has a low contact resistance of 0.4 milliohms and is offered in a 12-volt coil package as well. And again, we offer this relay in a single or double coil type. And the G9TB is offered in 2 different termination types, welding terminals and M8 securing screws. So just going into a little bit more about these relays and why they're great for charging applications. And really that's because you don't have to continuously power the coil while charging. So here we have a visual representation of the benefit of a latching relay. On the left here, you can see a standard single state relay that is non-latching and requires continuous power to the coil to close the contact and maintain operation. When the coil is de-energized, the contact will then reopen and turn off. With a latching relay, though, on the right, you can see here in this example, we're looking at a double wound coil, but the principles are relatively the same even with a single coil. So you would pulse the set coil with power, the relay closes and remains closed while operating without any additional power to the coil until you pulse the reset coil. The contacts will then return to the open state. So latching relays are really great for power savings and reducing your thermal output at the coil. So moving on, those are some of the highlight products from our AC relay lineup. I'd like to now move on to our high-powered DC relay product lineup. So for the DC lineup, we have, as noted in the legend here, to the upper right, both PCB type relays and screw terminal type if you're looking for higher power capabilities. I won't go into every product here, but you can see from the left side, we have some lower current relays for DC inrush and pre-charge circuits between 10 and 20 amps and 400 to 1,000 volts DC. And then within there, we offer our G2RGX, 10 amps, 500 volts DC, the G9EJ, 400 volts DC, 15 amps, and the G5PZX at 200 volts DC, 20 amps. And then for, higher power, more main high power DC disconnect, we have on the PCB side, I'd like to, call out 2 key product series. The G7LX, which can support 600 to 1,000 volts DC, 20 to 30 amps. And the G9KB series that has recently expanded to support 50 to 100 amps, 600 to 800 volts DC. Now, if you're needing something with even higher power, higher vibration characteristics, we have the screw terminal relays available to the right side here in the dark blue. And we're continuously releasing new variants of these relays, offering a low-cost option to contactors that the G9, and that's the G9E series here we're looking at, again, in the dark blue. So if you're looking to reach up to 300 amps at 400 volts DC or 120 amps at 500 volts DC, we have options in that area that we can offer. So going into, as I did with the AC side, I'd like to share just a few more, a bit more of the value of a couple of the DC high power relays that I just mentioned. The first is the G9KB series, which is our highest rated PCB mountable DC relay. We have both a standard and a newly released this year high capacity version available, improving the max voltage and max switching current from the standard previous version. The standard G9KB rated at 50 amps, 600 volts DC, and we have different ratings for switching at different voltage levels for the high capacity model at 600 volts DC, VDC, 100 amps, or 800 volts DC, 50 amps to meet those latest trends in energy applications for high voltage and current. The G9KB is also capable of reducing the total number of relays depending upon the application of its use because of its bidirectional capabilities. And I'll touch a little bit more on that in the coming slides. And then lastly, it's a safe and lighter weight gasless solution, and it's a great option for 15 to 40 kilowatt battery applications such as energy storage systems, EV chargers, including vehicle V2X, and uninterruptible power supplies. So a large part of our focus when creating these high power relays that are capable of is the arc mitigation and eliminating that arc without a gas sealed chamber for that arc suppression. So arcing occurs when these high power relay contacts are opened, and to mitigate that without gas, and we extinguish the arc by extending the arc using magnetic field force near the contacts. So the G9KB series utilizes permanent magnets for arc suppression and Omron designed simulation technology to optimize the terminal shape, magnet arrangement, and relay structure to control the temperature, pressure, flow, and magnetic fields within the relay, ensuring we can disconnect safely and eliminate any of that arcing, which is really critical to these high power DC voltage applications. And then the last relay I'll cover today is the G7LX, which can be used in pre-charge and low power type applications, lower than that of the G9KB there. This relay is a 2-form-A, and it's rated at 25 amps, 1000 volts DC. We have higher ratings for lower voltages as well, 30 amps, 600 volts DC. And like the G9KB, the G7LX is also a bidirectional DC relay with just a slightly lower spec in the reverse polarity. The relays feature a low contact resistance of 10 milliohms and a large contact gap of 6 millimeters because, again, it is that 2A relay. And this is available in 12 and 24 coils, and again features a holding voltage that can reduce the coil consumption from 2.3 watts down to 600 milliwatts. Now, just as I showed earlier on the AC side with the G9KA, the same holds true on the DC side. A low contact resistance yields a low temperature rise and thermal output of the relay. So on the left here, as you can see, when we spec these relays as low contact resistance, we typically spec it higher than what we rated at. So looking at the G7LX data here, the test data puts us between roughly 1 and 3 milliohms for typical output, and this directly correlates to that low temperature rise that we're seeing on the right. So in our testing, the highest product surface temperature tested was at 37.8 degrees C when carrying that 30 amps in 2 contacts at a holding voltage. So lowering the temperature of these thermal outputs of these relays really gives these a great value in these high power applications. And then lastly, to touch on that bidirectionality, I mentioned both the G9KB and G7LX are both capable of that bidirectional switching, but this is really the case for many of our DC relays that we have to offer. So in these designs, we're capable of eliminating arc in both directions, and it's designed the internal structure and magnet placement to make sure that the switching capacity is preserved for that bidirectional switching. So instead of needing 2 relays for charge and discharge, such as when using a conventional polarized relay, you need just one G9KB or just one G7LX to switch both directions in these types of applications. So again, just a note, we have a slightly different rating on the G7LX in the reverse polarity, as notated here on the bottom. So those are the highlight products from the DC side. I'd like to next touch on some of the focused energy applications and how these relays can be used in these applications. But before moving on to this section, I'd like to put out another poll question, and I'd like to understand what application you are currently seeking an AC or DC relay for. So moving on here to the applications, Omron has many high power relay solutions for EV chargers, and that includes level 2, mode 3 AC chargers and DC fast chargers. Our latching series is an excellent choice for those level 2 AC chargers, and our high power G9KA and G7EB series for the DC fast chargers. I won't go through all of this here, but I want to show some of the application usage. So in mode 3 level 2 AC chargers, we offer our G9KA 800 VAC 260 amp carry and our G7EB 480 VAC 100 amp series, as well as the G9TA and G9TB 60 to 120 amp 250 to 277 VAC for the AC disconnect from the utility grid. For single phase, you only need to use one of these relays, while in three-phase application, you would require one for each of the phases. And we also have lower power relays, such as the G7LX at 100 volts DC, 30 amps, and the G2RGX, 500 volts DC, 10 amps, and then the G6JY at 10 milliamps, 800 volts DC for ground fault detection applications. And looking more here at mode 4, level 3 DC fast chargers, we have a wide variety of offerings for the different applications within. For rectifier units, which converts the AC grid power to DC, we offer our G7EB and G9KA series for that 100 to 300 amp, 480 to 1000 volts AC to ensure AC grid disconnection. And for the rectifiers, AC inrush bypass circuit, our upcoming G6QG is a great fit at 55 amps, 480 VAC, along with the G7EB again for the higher inrush requirements. The DC to DC converter is used to adjust the voltage level to the various vehicle requirements, delivering a controlled transfer of that energy to the battery. So for the DC disconnect in the DC to DC converters, we offer our G9KB series, 50 amps to 800 VDC. And we also offer the higher power screw terminal G9EC, 100 amp, 1000 volts DC. And then coming soon, we'll be releasing our G9EK, 120 amps, 500 volts DC. And at the bottom here for the DC precharge and discharge circuits, our G7LX 25 amp, 1000 volt again, our G2RGX 10 amps, 500 VDC. And then lastly, for matrix switching networks, which connects EV charging modules in parallel or series to allow for the charging station to provide that wide range of voltage and power requirements. The matrix switching networks, we offer the G9KA with DC ratings of 1000 VDC, 200 amps carry only. So many product solutions for both AC and DC sides of these DC fast charger applications. So I won't read through all of this, but just to touch on it, another one of the major focus for us in the energy infrastructure space is PV inverters for DC to AC conversion in homes, buildings, and factories, and also battery energy storage systems used in conjunction with these PV inverter systems to store large amounts of power for use during outages or during peak power cost timing for both AC and DC application requirements. For these applications, I'd like to highlight products like the G9KAE, the G9KBE, and the G7LX, just as a few of the many high power relay offerings for this application. And to go into a little bit more, here I'd just like to show this is just one example of the many different types of configurations for PV inverters and battery energy storage systems to demonstrate our solutions within these applications. So for AC on the right side here, for AC shutdown of the utility grid or home residence, utilizing our G9KC multi-pole 40 amp 480 VAC relay, the G7L PV 30 amps 280 volts AC, or the G6QE at 36 amps 250 volts AC. For the DC discharge and DC inrush protection, similar to that of the DC fast charger, we again have our G7LX, G2RGX, and G5PZX available. And just to highlight, the G5PZX can be used to combine in series, two of these to reach up to 400 volts DC at 20 amps. And then for rapid shutdown from PV panel side, we have our G9KB and G7LX series. For ground fault detection from the PV panel, we again have the G7LX, the G2RGX, and lastly, for safe DC shutdown from the battery energy storage system, our G9KB and G7LX series. So this is just, again, one example of the many different configurations for utilizing PV inverters and battery energy storage systems. And we have products that can fit within these applications. For my last slide today, I would like to share with the group, with everybody, that Omron will be attending RE Plus this year in Anaheim, California, September 9th through the 12th. We'll be located in Hall E, booth 13066. So if you're attending the show and would like the opportunity to speak with you more about your high power relay solutions and how these can be integrated into your applications, we'll also be showcasing some other technology at the expo. And then on the next slide, you can find my contact information. So please feel free to reach out and we can schedule some time to meet at the show. Or if you won't be attending but would like to further discuss your application or our relay solutions, again, please feel free to reach out to me. And before closing here, I do have one final poll question. I would like to know what product discussed today was most relevant for your project. So that's all from me today. Again, I would like to thank you all for your time and joining us today. I'll now pass it back to Dale to get us started with the Q&A session.
Well, thanks for that. Really a great in-depth presentation. I was really fascinated by the use of magnets for arc cutoff. I was not familiar with that technology, so I'm going to have to go learn some more about that. But until I do that, we have some excellent questions already from our audience. So I'll remind everyone that there is still time to submit your questions and we'll try to get to them. Just type them into the Q&A section on your screen. And with that behind us, Zach and Kyle, you ready to answer some questions?
Absolutely.
Thank you.
All right, let's go with the first one here. What are Omron's relay advantages over your competitors?
Yeah, great question. I think there's several advantages, and a lot of which I kind of covered through there. So I think for starters, I think our high switching capacity, I discussed in the very beginning our G9KA, which is our highest PCB AC relay. And this really led the market upon its release for PCB relays. We have really great offerings on the DC side as well with the G9KBE and the G7LX. So I think that, first is a high switching capacity, and then certainly the low contact resistance ratings that we have. We've really dedicated a lot of our engineering resources to emphasize reducing this as much as possible. And you can see that really translates to that much lower heat generation. So a great advantage, I think, to Omron relays. And then I think lastly, I would say our compact size. We're really put focus on developing these high power PCB relay solutions with small form factors. So it really gives our customers the ability and advantage to have some flexibility when it comes to their design and also reduce the overall size constraints of their design.
Excellent. Thanks for that. Our next question is, will Omron help transition from other switching types to these relays?
Yes. Yeah, absolutely. One of the really great things of Omron's focus in these energy applications is the dedicated global team that comes along with it. So we have a group of dedicated engineers and product support specialists to really assist with any design questions, integration, or really anything you might need to switch from contactors to PCB type relays. So if you do need any support, all you need to do is reach out to your Omron representative and we would be more than happy to assist in that.
Okay, well, that's a good, helpful resource for our audience. Our next question here is asking, are there other AC or DC relays from Omron that you didn't cover today?
Oh, yeah. Great question. For this one, I'll pass over to my colleague, Zach Hendricks, our relay product manager, who covers our full lineup of AC and DC product offerings.
Sure. Thanks, Kyle. And of course, yeah, there are more. There's a good deal more, actually. And on one of Kyle's earlier slides, we got a glimpse at some of those other series. So he went through a couple of them and he showed that, we do support other industries outside of energy. In fact, our high power relays are a major focus of ours, but the lower power relays are the majority of our existing products. As through the previous decade, we've developed a lot of business in various applications and industries. So just to give you a little flavoring, we have electromechanical and solid state relays for switching below 3 amps. So this is like test and measurement type relays, both multi-pole and single pole relays, latching and non-latching. And then the most prevalent section is our power PCB relays. So that's the mid-current range from 3 to 40 amp switching. And that's form A, B, and C contacts. So transfer contacts are just open closed. Also, we do have some automotive PCB and plug-in terminal relays. And those are great for 12 and 24 volt battery applications. So really a pretty wide variety. But we're really open to assisting with relay selection. If a design calls for something that's not necessarily high current or voltage, you can contact me or you can go through Kyle. Or if you already have a contact, a sales member of the Omron team, and we can help pick the right relay for your design.
All right, thanks for that answer. Our next question is asking, do you do any short circuit testing for inrush current? This person said they did not see any call out in the spec sheets.
I can answer that too, Kyle. It's general for relays, so it's not a common request for our lower products. But as I've been working with these high power relays and releasing these over the last, say, 5 years, I have seen that need pop up for short circuit and rush testing just on the high power side. So typically our testing is based on the requirements of each customer. So we don't have official ratings on the data sheet or something like that, but it is supplementary test information or testing that we can perform for the high power relays. But the usual outcome we're looking for is to generate from that testing is either we're seeing no welding of the relay contacts or malfunction of the contacts or the contact switching structure due to something like electromagnetic repulsion. And that's like when passing thousands of amps through the contacts. So I've seen it for lower 1,000 amps of current up to 5,000 amps for various amounts of milliseconds, depending on the requirement, and to check if fail or no fail. So if you need that, that's also something our engineering team can provide for you.
Interesting. Okay. Next one is asking, says, you talked about auxiliary contacts for multi-pole relays. Do you have plans for more auxiliary contact relays?
Yeah, we've really recognized the trend and need for auxiliary contacts for that weld detection in these high power applications. And so we're definitely seeking to integrate that solution into our future roadmap. And so for that, please stay tuned, and hopefully we'll have some announcements by our next webinar.
Sounds good. We'll look forward to that. This questioner is asking, are high power relays built to withstand or handle loads with current inrush?
I can take this one too, Kyle. It's kind of related to the short circuit inrush question. Really, the short answer is no, not really. The high power relays are built to carry and disconnect the high level loads. As Kyle was going through, you saw some of those specs. You saw a lower make, a high carry current, and then the maximum break amperage. Because we want to make sure that we can disconnect the high level loads and have that safety disconnect when needed in emergency scenarios. They're not necessarily developed to withstand very large inrush or severe contact make conditions like motor or capacitive loads. So it's highly recommended to build inrush protection into the circuit or utilize one of Omron's lower current relays to build a pre-charge inrush protection circuit if you have capacitor banks that you have to charge. That said, the high capacitor, the high short circuit amperage side, we do have ratings for the very, very small large inrush, but large inrush periods, I should say, but just not, that's not what they're designed for.
Okay, excellent. This question is asking, are there requirements for specific mounting orientation?
I can take this, Zach. Yeah, we do have specifications for mounting orientation depending on the relay model we're discussing. And this is really due to the spec for operating voltage and electrical durability. So it's really important to reference the data sheet and then mount accordingly to those precautions in order to ensure that the relay is going to operate at the rated specification. So do check that when looking at the data sheets, please.
Okay. Speaking of data sheets, and this kind of builds, I think, on a previous question, but can you provide test data beyond what is on the data sheet?
Yeah, that's a very good question. And yes, we certainly can provide additional test data beyond what we have listed on those data sheets. And this again comes back to the earlier question where we have that dedicated global team to really assist in supporting and providing additional test data, additional criteria, what have you. So just simply reach out to myself or Zach or your Omron sales representative, and we'll be happy to work with you to support those needs and requirements.
Okay. Can the relays be used in high vibration environments?
Yeah, here again, I would, note to always check the vibration and shock specifications on the data sheet. But generally speaking, no. The high vibration can really lead to improper contact closure, which can lead to risk of relay failure. And that failure or misaligned contacts or bouncing contacts may be dangerous in these types of applications. So, always refer to the spec sheet for the vibration and shock resistant specs.
And this question is asking that they say, I know Omron does sensors as well. Do you have plans for new products outside of relays?
Yeah, great. Another great question. And thanks for asking, because I didn't really touch on any of our upcoming sensor products. I'm really focused here on the relay side. But, we continue to develop our sensor technologies, and some of which we'll actually be displaying at RE Plus next month, including our autonomous charging with our TOF sensor, which has a socket detection algorithm built in. We also have a weather sensor for PV and outdoor weather tracking applications. It's capable of detecting 7 key weather elements, including wind direction, wind velocity, temperature, humidity, barometric pressure, light, and rainfall. And then we also have, we'll be featuring our energy management module for power demand and distribution control. So if you're attending RE Plus, please come by, see these demos and sensors. Or if you're not attending but would like to get more information about these sensing products, please don't hesitate to contact me.
Very good. Well, it looks like we're kind of up against our time limits here. Kyle and Zach, thank you again for your presentation and a really great discussion during this Q&A.
Yeah, thank you so much for the time, everybody. Thank you.
Yeah, thanks to our audience for your participation. Our apologies if we couldn't get to all of your questions. In just a moment, you'll be redirected to Omron's website to view solutions for automated test equipment. You will be able to view this session on demand by using the same link you used to view this webinar today. Thank you for your time. We look forward to seeing you at another live session again sometime soon.